Hello there. I tried to put together a variety of capacitors here to show you. As you can see, there's quite a few, and this doesn't even scratch the surface of what's out there. Pretty much any two metal plates with a distance between them is a capacitor, so you can imagine there's endless varieties. But these are pretty common. Some of these are from the 20s or 30s. Most of them are modern. Let's start with something you'll recognize, I think. These are ceramic capacitors here. You've got really small ones. One of them is a 1 nanofarad and another one is 100 nanofarad. Really, really small values. Here you have electrolytics. Really, really tiny ones. 10 volt, 10 microfarad. Larger ones. Here's multiple in one package. Here are some very large values. This is a 3-pin capacitor, but the third pin's actually structural rather than connected to anything. Fairly common pins on the bottom of this one as opposed to terminals. This is a type Fp capacitor. It's also known as a twist lock. It's a chassis mount. It mounts directly to a metal chassis, and the terminals protrude through the bottom of the chassis. So these are all PET capacitors, polyester film. You can see right through the polystyrene into the metal foil. This here is a Kapton capacitor. It's made of Kapton, K-A-P-T-O-N. It's a type of polymer. This is a paper capacitor. It's alternate sheets of foil and paper rolled into a tube and dipped in wax. Very simple. Similar in design, but this one is plastic. These are tantalum capacitors. They're similar to ceramic, but they are made of tantalum. So the plast cap, early plastic capacitor. This is a CDE high voltage capacitor. It's a ceramic casing, so it's cracked so you can see the foil in it a little bit. Maybe I'll tear that apart later. This is just a chassis mount capacitor. This right here is a starter capacitor. This would be used in any AC induction motor. This is fluid filled. It contains a mineral oil to dissipate the heat more effectively. This can get quite hot quite quickly. So often when you have an AC induction motor fail, it's because this is overheated and shorted. You can usually tell because it sprays mineral oil everywhere. You have a similar situation in many other devices that require a starter capacitor. The function of the starter capacitor is to cause the current to lead the voltage. If you apply voltage and current in phase to an AC induction motor, it won't turn. It'll just lock up and roast. The only way to get it to turn is to cause the current to lead or lag the voltage. In this particular case, capacitor is used to cause the current to lead the voltage, which pulls the armature around, starting the motor. This is a mica capacitor. It's a fixed capacitor. Like all of the ones we've looked at before, it has a fixed value, but it's made of mica. It's actually just two flat pieces of silver folded around a sliver of rock, basically. Again, a very old capacitor, very simple capacitor, and still used heavily today, particularly in radio frequency circuits. this is basically the same capacitor, except this one is adjustable. The spacing between the plates is adjustable. You still have a mica insulator in here. Again, same type of thing. This would feed through maybe into an adjustment panel or whatever, where you'd have various fine-tuning adjustments. This is similar to the mica tunable capacitors. No mica. This one, I believe, is just an air dielectric capacitor, which means that there's air between the metal plates and nothing else. This is air dielectric here. This is a large tunable capacitor. So you have these two plates which mesh. In that position, there is effectively no capacitance. It's not exactly no capacitance. And then this would be maximum capacitance. This is probably 50 picofarads. Again, 0 picofarads, 50 picofarads, 25 picofarads. Very simple device. This would have been used in an AM radio, for example, or a shortwave radio. This particular setup here is pretty common in AM medium wave receivers like you'd have in your kitchen or next to your bed. Very simple device. It hasn't changed much in the past, arguably 80 or 90 years. Now back to simple capacitors. Let's just take a look at this for a moment. These are 2 strands of insulated wire, ordinary insulated wire. I have stripped one end, about 1/4 inch. Now, a magical thing happens when we place these two like this. Well, now we have 2 pieces of metal separated by an insulator, which makes this a capacitor. Very simply. These are used in radio circuits for RF detection, RF sampling, or even in VHF and up into UHF frequencies. These can be used for tuning, perhaps in an amplifier, a fine-tuning adjustment in an amplifier. To make the adjustment permanent, you just twist the wire together there, and now you've got a capacitor. So this type of capacitor here is known as a gimmick. Another little gizmo we have here is a oscillator. This is an RC unit, a resistor-capacitor unit, PMR 2026. It's the model number. It's apparently 0.5 microfarads in series with 150 ohms. If you want to do the math on that, you can figure out what frequency this oscillates at. Might give you a little bit of a hint. In an earlier video, we salvaged an electric condenser microphone from a telephone. So you might wonder, well, what's a microphone have to do with capacitors? Electric condenser, as the name implies, is a condenser. And condenser is really just another name for capacitor. The electric condenser microphone here will vibrate at whatever frequency of audio is entering the portal in the front. It's just sort of mechanically moving the plates of the capacitor in response to the audio. That's why you always have to supply power to an electric condenser microphone. Being a capacitor, it doesn't function until it's charged. So let's veer off into the weeds and talk about something that's not a capacitor. This is a battery. This is made up of a number of alkaline cells. So now batteries seem similar to capacitors. They sort of have the same sorts of functions. They store charge. So how are they different? Right? I mean, it would be easy to assume that they're really just different forms of the same thing. However, this capacitor here, it stores its electrons in an electric field between two metal plates and has some chemicals similar to a battery in it, electrolytes, that are supplying excess electrons to the plates in order to hold in the field. It's just sort of a kickstart to make it function. Whereas the advantage is you have a much higher power density on a battery. It's a little counterintuitive, but a AA battery actually holds a tremendous amount of power. This 9-volt is considerably weaker than a AA, and even it's quite powerful. So they're sort of the opposite of each other, really. If you need to provide a small amount of current for a very long period of time, then a battery is going to win out, always. The energy density of a battery is tremendous. Energy density of this capacitor is microscopic compared to this battery. But the capacitor has the advantage of being able to release all of the energy that it stores safely in milliseconds. So this is battery is a slow and steady current, and a capacitor is a short burst of a lot of current. So as I was saying earlier, this capacitor is damaged somewhat, so maybe we can learn something about how it's constructed. I'm wearing safety goggles, so there. Interesting already. It looks like aluminum foil. I'm going to guess that's because it is. Never leave the hammer. So miles and miles of this. Alright. Well, suffice to say it's going to go on for another 100 feet or so. Just to review some of the storage techniques I use. The 5.7 liter shoebox made of plastic. I have the capacitors in bags here. Each bag has a like capacitor. 330 microfarad, 250 volt, 50 microfarad, 250 volt, 200 microfarad, 200 volt, 330 microfarad, 250 volt. You'll notice that these are all about 250 volts. So I have all these organized into bags inside here. Air dielectric capacitors. Air dielectric capacitors are used for tuning, usually radio circuits or things like that. Various different kinds. I have all of my air dielectric capacitors in this tub. This is just a mess of capacitors that are unsorted. If there's something I don't know what it is, often I'll find a shoebox or a tissue box filled with capacitors like this, and these aren't exactly worth my time to sort out. So here's an ancient piece of technology here. It still works to this day. This is a 0.047 microfarad 1000 volt DC capacitor. And behind it here is a 1960s vintage Konar instrument. These were sold as kits They were part of a training course, so as you were learning to become an electronics technician, you would build this kit, and it would become part of your test equipment. So I have this set to the 0.5 microfarad scale. Covers 0.001 microfarad to 0.5 microfarad. I have a 0.047 microfarad capacitor in my hand. Let's hook it up here and see what happens. It's just resting in the terminals there. I have it set to about 75 volts. You can use that for testing capacitors, make sure that they're functioning properly, or just it's called form them. After they've sit for many decades, they'll dry out, and this device is also capable of reviving them to some extent. However, let's see what we got here. We want to measure the capacitance of this, so let's adjust it until we get a null on the eye. There we go. And just fine tune that here. And you will notice we are at 50, which is 0.050 microfarads. So that is well within tolerance of that value there, 0.047. 0.050 on the meter, 0.047 on the capacitor. That is a Konar Model 311 resistor-capacitor tester. Well, if you made it to the end, I've got just a little bit of a bonus for you. This will probably be of most interest to ham radio operators and anyone building an antenna tuner for transmitting purposes, high power especially. And that is this little device. That is a 500 picofarad 20,000 volt DC capacitor. It's kind of like unicorns. You don't see these very often anymore. They're really hard to find too, and they're very expensive if you do find them. But keep an eye out for these. If you can get these at a good price, snag them, even if you don't need them. They are rare and very useful for tuning antennas, especially when you're dealing with a couple of 1,000 watts. Thanks for watching. I hope you enjoyed.